Welcome back, everybody. This is Circle Test Review 2, Part 3, which is question number 3, and where we have on complete diagram, figure A, triangle ABC, inscribed in circle O, and AB is diameter of circle O. AB is 20, BC is 16, and the measure of minor arc AC is 74. So we have 5 things to find here, ladies and gentlemen. Hopefully, knowing our constants, our circles, we will be able to find these things. So before we start, a shout out to my coworker, Ms. Huang, another teacher of the honors geometry. And so hope she's doing great, and all her students hopefully are doing great as well too. So yeah, it's a tough time, ladies and gentlemen. Want to just remind us that, hey, we got other teachers out there who are doing their best to make sure we learn material. So shout out to her, and I'll be making shout outs to my fellow workers, co-workers and all, because, just remember that school is a big place and we work all together. Okay, so, all right, ladies and gentlemen, part A, find the measure of angle ACB. So angle ACB is this angle here. And one of the things we know is that diameter AB, what it does here is that it cuts the circle in 2 parts. So that would mean that this is going to be 180 degrees. Sorry, my handwriting is not so great. I'm going to erase that and make it a little more clear. Sorry. So here we go, 180 degrees. All right, and so that arc is 180 degrees, and so angle ACB intercepts the arc AB. And it's neither minor or major because it's a semicircle. And so we know, and again, so here's the idea. When I do these problems, I'm going to show you, I guess, when on my exams, just the template of what I'm looking for. I'm not looking for just the answer. I'm looking for the rule that helped you find the answer. So here, since angle ACB is inscribed angle, the measure of angle ACB is equal to, now the measure of inscribed angle is 1/2 the measure of the arc intercepted. So everything is about the arc intercepted. And in this case, the measure of the arc intercepted here, well, the arc intercepted is arc AB. And so we take 1/2 of 180 and we'll get 90 degrees. So there you go, 90 degrees. Box that answer. Okay, so that's 90. Now, the next question to try to look for is angle BAC. So again, angle BAC is very similar to the type question of part A. So the measure of angle BAC, because BAC is also an inscribed angle of the circle. Because remember, inscribed angle means in this case that the vertex is on the circle and the sides are going to be 2 chords of the circle. One of them just happens to be, in this situation, a semicircle, but this one's not. So this one's not. The arc intercepted is going to be arc BC. So I'll make that purple. And so we want to find this measure. Well, to do that, we're going to do a little, well, first off, we'll write the rule down. So it's going to be 1/2 the measure of arc BC, the minor arc BC, of course. And so we want to find arc BC. Well, the full circle is 360. So 360, and we'll take away 180, and we'll take away 74, leaving us the leftover arc. And the leftover arc in this case is going to be 106. 106. So 106 degrees is going to be the measure of arc BC. So let's list this here. 106 degrees. Oops, I went to black. 106 degrees. And so for us, we want to find the measure of the angle is 1/2 the measure of arc BC, which is 1/2 the measure of arc, which is 106 degrees. So that's going to be, in this case, a measure of 53 degrees. So that's going to be an answer for part B. Now notice in this case you had to show where your measurements are from, how you're getting your arc measurements and all. Again, if you're just going to put down answers, okay, answers out of any work will not get you much. Will basically get you 1 point. Okay, and so that's not going to be helpful, and you're like, oh, how come I didn't do well? Well, if you don't show me work, I can't give you credit. Okay, so here we go. Part C, this now has to do with lengths. And so we know the measure of length AB is going to be 20. So let's put that as 20. This is 20. And we know the measure of BC is 16. So this is 16. Now, At this point, well, here's the thing. I know in this case that this is 52 degrees. And if you want to use law of sines, you most definitely can. Most definitely can. All right, because you find the measure of angle ABC and use that. But you know what though? Here's the thing. We're trying to find the measure of AC. This is a right triangle. This triangle here, our triangle ABC, is a right triangle because it has a right angle. And therefore, to find the third side right triangle, we can use Pythagorean theorem. So here's what we're going to do. We're going to say in this case, AC squared plus BC squared, which is 16, equals AB squared, which is 20. And therefore we get AC squared plus 256 equals 400, or in this case, AC squared is equal to 144, because it's subtract 256 on both sides. Okay, so now we don't want AC squared, we want the measure of AC. So we're going to take the square root of both sides and take the positive value. Here, the measure of AC is going to be 12 units. Now, I am compressing all this work into a small space here, ladies and gentlemen, and for the space of the video here, it's a little tight. On your test paper, please use all the space. Yeah, so, okay. So now we're up to part D, now area triangle. Now again, area triangle, we could use our formula for area triangle because now that we know that AC is 12, all right, AC is 12. And by the way, there's one way to do this, ladies and gentlemen. We can use our area triangle formula, which is going to be 1/2 AB sine C. And we could get 1/2 times 20 times 12 times the sine of 52 degrees. But because this is going to be the area right triangle, we can just use our area formula, which is 1/2 base times height. And the base and the height in this case are going to be the two legs of the right triangle. So that would be 1/2 times 16 times 12. And so 1/2 times 6 times 12 is going to be 96 units squared. Okay, so that would probably work out. Now, I will say in this case that if you did try using the area triangle formula, it would round up to 96 because sine of 53 is maybe not so perfect in as far as answers go. So this method works out great. And finally, for part E, area of a triangle, or a circle, in terms of pi, area of a circle is equal to pi times the radius squared. And our radius, since our diameter is 10, our radius is 20 divided by, well, our diameter is 20, our radius is 20 divided by 2, so it will be 10. Okay, so we're going to use in this case pi times 10 squared. That gives us an area of 100 pi units squared. So these are the answers for part D and part E. Okay? All right, so this is pretty straightforward. Keep in mind that, some of the questions you'll have on your exam might be a little more challenging, so kind of look at both reviews to be able to get a good idea of what the level of difficulty is. They'll be varying from things you should be okay with. Notice, however, we use Pythagorean theorem here in area of triangle, and there are different ways to approach this, ladies and gentlemen. So keep in mind that you will probably need to use some of the other skills like law of sines, the area of triangle, maybe, possibly law of cosines, who knows, all right? But keep in mind that you're going to have, a variation of different things we have learned from geometry applied to our circles. Okay, but hopefully this was helpful, ladies and gentlemen. If you found this helpful, please give this video a like. Hopefully that you're just looking here to confirm your answers at this point in your review. If you're stuck or have any questions or unsure, please add questions or comments in the comment section below. If you're new to the channel, if you have not subscribed yet, please subscribe to the channel to be and then turn on notifications to be alerted when new videos are added to the channel. All right, so again, good luck, practice, okay, go over these things and be ready for our test. Thanks so much for watching. Take care and be safe.